In the last video, one of the types of computations we did was converting from base 10 into other bases. What we're going to do in this video is give you an alternate method of doing the same thing. This is completely optional, by the way. If you are happy with the other way of converting from base 10, that's fine. This just gives you another way of doing the same type of problem. So as I mentioned, we're going to look at an alternate method for converting a number from base 10 to other bases. And before we get into that, we're going to first look at what happens when we recursively divide a number and the preceding quotients by 10. So, and this is by 10 in base 10, our normal base 10. And then we're going to extend that method and use those types of computations to convert numbers from base 10 to other bases. And we'll work an example to show how this technique works. So we're going to begin by considering this big old number in base 10. It is 4,739,284. And we're going to see what happens when we divide the number by 10. Well, when we do that, we get a quotient of 473,928 times 10 and a remainder of 4. Two important observations. First of all, that 4, that is the remainder, that is the units place. And the quotient, it turns out, has all the other digits in it. In fact, it's basically take the original number and remove the 4 from it, and you get the exact quotient. If we do this again, when we divide the quotient, 473,928 by 10, we get something similar happening. We get a quotient of 47,392, which is all the digits past the tens, and we get 8 as our remainder, which is our tens digit. So again, the remainder place is the tens place, and the quotient has all the other digits. And if we keep on going, take the new quotient and divide that by 10, our remainder is the hundreds place, and the quotient has all the other digits. So we can conclude that by recursively dividing each quotient by 10, the remainders generate the next highest place value. And we can use this to find all the digits of the number. Now that's silly when we're trying to convert a number from base 10 also to base 10, but it's going to be very useful when we're going to convert a number to a different base. So notice that these computations only depend on using the place value. And that means we can do this with other bases as long as we're flexible about what we mean by dividing by 10. Right? So here we're dividing by our 10 with our 10 fingers, right? But if we're in base 4, when we divide by 10, we, for instance, divide by 4 instead. So let's use this technique to convert the number, well, it's still the same number, 4,739,284, but now we're going to convert it to base 16. So we're going to do exactly what we did before, but when we say we're dividing by 10, what we really mean is we're dividing by base 16, because that represents the number 10 in this numbering system. So when we do that the first time, we divide it by 16, we get a remainder of 4 and a quotient of 296,205. And that tells us a couple of things. First of all, it tells us that 4 is the units digit, and it tells us that if we want to find the other digits, we've got to divide the quotient, 296,205, by 16 again. So let's go ahead and do that. When we do that, we get a new quotient of 18,512, a remainder of 13. Now 13 in base 16 is the digit D, so that means D is the tens digit. And we keep on going, right? We take 18,512, we divide that by 16, we get a remainder of 0. That tells us 0 is the hundreds digit. We take our new quotient, 1,157, divide that by 16. We get a remainder of 5, which then becomes our thousands digit. We take our new quotient, 72, divide that by 16. These computations are getting a lot easier now. We get a remainder of 8. That means 8 is our 10,000s digit. And then finally, we divide 4, which is our quotient, by 16. That's a silly computation. We get a quotient of 0. The remainder is 4, telling us 4 is the 100,000s digit. So if we put those all together, we get 4850D4 as our hexadecimal representation of our number. So there are a few activities on the PDF file converting between bases that you can practice this technique on, or you can practice the other technique if you prefer that one. I should note that those particular problems won't be on the quiz. This is again just to give you some practice converting between bases using this new technique.